Hello guys, so today I'll be solving this problem which is sum of distances. So this is problem of the day. So what we have been given is a zero index integer array nums, and we have to create an array of length same as nums where array I is the sum of I minus j for all j such that nums of I equal to nums of j equal to nums of j, and for j is not equal to I. If there is no such j, set array I to be 0. Okay, so the problem is pretty simple. So it's a simple implementation kind of problem. So what we have been given, so if I take this example, so we have been given 1 3 1 1 2. Okay. So as we can see, if I write the indices 0 1 2 3 4, okay, so I can see 0 2 3, they are of same values. Okay, so what I need to do is, for when I'm building, so this is nums of array, right? So if I'm creating answer array, so for 0, okay, so for this position it will be 0 to 2 distance, okay, which is 2 minus 0, okay, and plus then the index 3 also contain 1s, which is same as index of 0, which is like same as nums of 0. So this, so from this index, okay, the distance between to all those indices which contain the same value, okay, that I need to give. Okay, so answer of 0 will become 5. Okay, now for 3 I cannot find any indices, right? So I will simply put 0 here. Okay, cool. Now for 2, okay, now there is no symmetry here, okay, because the answer that I get from 0 is not same as what I will get for 2. If you look at here, from 2, okay, so on its left we have uh, 0, okay, that is at a distance of 2 units. Okay, now on the right I have 3, like index 3, right, which has the same value. So if I take the distance, it is 1. So the summation of all the distance is 3 here. Okay, not 5, 3. Okay, because it's depend upon the position, right? So wherever the index position is, okay, so based on that we have to look at the left distances and we have to look at the right distances. So that's the core idea here. So yeah, let's solve for 3 also. So now for 3, we do not have any index on the right of this element which has the same value as 1. Okay, so we only need to look at the left indices. So we have 0 and 2. So from this index, okay, the distance from 2 is 1. Okay, now from this index the distance from 0 index is 3. So 1 plus 3, that is 4. Cool. So now for index 4, now for index 4 we have a value of 2. Now nowhere in the array I have an value of 2 other than index 4, so I will simply write 0 here. Cool. So this is how we will proceed. Now a simple brute force way to solve it is like you can iterate over all the indices. Now you like basically you can have 2 for loops. Okay, one for I in range of nums, okay, and another j in range of nums again. Okay, now wherever I is not equal to j but our nums of I is equal to nums of j, okay, I can simply update the answer for the ith index as the absolute difference between I and j. Okay, assuming I have an answer array of size n. Okay, so this is like the trivial brute force approach. Okay, now if I look at the constraint, the length of nums, it can be 10 to the power 5, okay, and the values can become 10 to the power 9. Cool. So here if I do this, so this will give me a time complexity of big O of n square, okay, which is not good with n varying between 1 to 10 to the power 5, right? Cool. So we have to think something smart. Okay, cool. Now let's think of a situation. Okay, let's assume. Okay, so let's consider we have some nums of I here. Okay, so let's think about it. Okay, let's consider the value nums of I. Okay, now let's say that nums of I is present at, let's say, some p1 index, some p2 index, some p3 index. Okay, like that. Let's say there is some pk index, and let's say the frequency of value in the whole nums is some m. Okay, so let's say m. Okay, so I'm basically saying like values frequency in nums is m. Okay, so if the frequency is m in nums, then that means I will get m indices containing val as the nums of like wherever whatever indices I have taken, that indices value at nums will be val. Okay, cool. Now if you look here, okay, now our task is for each of those each of these indices I need to get the sum of the distances, right? So basically if like p1 to p2, let's say there is some d1, p2 to p3, there is some distance, let's say d2, like that. Okay, now let's say I want to find the sum of distances for my pk element. Okay, I have to consider all the distances from pk to p3, pk to p2, pk to p1, like that. And then from right also, like pk to, let's say there is pk plus 1. Okay, similarly I will be going to the right. Okay, and finally up to pm. Okay, now if you see here, okay, so for some pk index, okay, I need to get all the left summed left distances sum, and I need to get all the right distances sum. Okay, so the answer for pk, okay, it will be pk minus pk minus pk minus 1, okay, plus pk minus pk minus 2. Okay, like that I will be going to pk minus p1 index, like the first index where val happens in nums. Okay, similarly these are all the left distances. Now for the right distances I also need to do something same. Okay, there will be pk plus 1 minus pk. Okay, similarly pk plus 2 minus pk. Okay, and like that I'll be going to the mth index minus pk. So these are all the right distances for my pk index. Okay, now if I look at here, okay, now I can like group all my pks from the left distances, and similarly I can group all pk from my right distances. So if I do that, okay, so there will be pk, right? So there will be k minus 1 values here. Okay, so if I look at here, okay, so the distances that I will get is k minus 1. Okay, and the right distances I'll be getting p minus k. Okay, now in order to like make this sum as m, okay, because what I need to do is, so basically the constraint here is I have m indices, right? So the number of differences that I will be getting is m minus 1. Okay, let's try to make this m minus 1 to m. I'll tell you like how this can make our life simple. Okay, so if I do this, okay, this will become so I can add something like pk minus pk. Okay, let's say this is one more additional term. Now when I'm adding this, okay, I'm not changing anything to the answer of pk, okay, because pk minus pk is 0, so 0 is not doing anything, okay. But with this, now when I'm grouping the value, I will get k pk's in my left differences, okay, and these I can group with pk plus pk minus 1 plus pk minus 2. Like that, I'll be going towards p1, okay. So this, I have grouped all the left side indices, okay, of pk, okay. Now for right side indices, I'll be getting something similar, okay. This will go like pk plus 1 plus pk plus 2, okay, plus pm, okay, and here I'll be getting m minus k pk's, right? Cool. Now if I look, so I have a k pk's here and I have m minus k pk's here, okay. Now if I see, this will be k minus m plus k, okay. I'm just grouping everything, all the pk coefficients here, okay. Pk minus this, I can take like a summation of all the pi's from 1 to k, okay, and this I can take as summation of all the right indices of k's, like with respect to k, okay. So this is starting from k plus 1 to m of pi. Cool. So the answer for any pk index, okay, is simply this, okay. So if I apply this formula, so I can simplify this term also. So this will be like 2k minus m pk, and the final formula coming out to be pi summation from 1 to k, okay, and k plus 1 to m, so all the right indices sum, okay. So this will be my answer for pk. Cool. So if I apply this formula on this array, so this will be 1 3 1 1 2, okay. So here if I solve for this one, let's say, okay, so what I will be doing is, so here I have 0 1 2 3 4, these are my indices, okay. Now here m designates the frequency of my element, okay. So how many times I have 1, okay, m here is 3, okay, 3. Now here k designates how many ones including this position on the left I have, okay. I have 2, okay, so k will be 2, okay. So I have found k2. Now this is now this summation basically designates including my current index, which is 2, okay, the summation from 2 to all the indices that contain 1, okay. So summation of 1 to k of pi will become 0 plus 2, that's 2, okay. Now here this summation basically designates all the indices that contain the same value as my kth index, okay, or my pkth index, okay, and they are on the right of my pkth index, okay. So if I look at the summation value of this guy, this will be k plus 1 to m of pi. This will be, I can see only one index, which is this 3, right, which is on the right of my current index, okay, and it contains the same value as my current index, okay. So I will write 3 here, okay. Cool. Now if I plug in this value, okay, so earlier we have gotten 3 as an answer here, right? Now if I plug in the value here, okay, so the answer of my current index, which is 2 here, this will be 2 times 2 times of k, which is 4, minus m, which is 3 here, okay, times pk, which is 2 here, okay, minus this summation, which is 2, okay, plus the right side distance is the right side indices summation, which is 3, okay. So if I solve this, okay, so this is 4 minus 3, which is 1, then I have a 2, so I have a 2 minus 2 plus 3, which is 3. Cool. So this is the mathematical formula that we need to code, okay, and this is something you can consider as a prefix sum, okay. So these are all the indices summation, okay, of my pkth index, which contain the same value, and this is all the right side indexes which contain the same value with respect to my pkth index, okay. So I'll be using some hash maps to calculate the frequency of my pkth index element, okay, and this k value I can easily get, okay, so by some running count, okay, like how many elements to the right of my current index, including my current index, are of the same values, okay. Cool. So I'll be basically coding up this formula, okay. So I'll be first doing it with Rust, okay, then I will show you the code for Golang and C++. So just bear with me, okay. So first I need to get the number of elements, so I will say n equal to, I'll just zoomify a bit, okay, I hope you guys can see it, okay, n equal to nums of len, okay, cool. Then I need to create a frequency map, so I'll be using std collections hash map. Cool. Now I'll be creating a mutable frequency mapper. I'll be saying hash map of my key is of i32 integer data type, and my value is of i64 data type, because I need to get i64 vector, okay. So here I'll say hash map new, okay. So the reason I set it to i64, because I'll be using these frequency values of this dictionary, right, to compute all this. So I should be storing it as i64. Cool. Now first thing first, I need to store all the elements frequency, so I'll be taking the reference of my nums. I don't need to borrow any values, okay. Cool. So for every element in my nums, I'll be storing their frequency, so this will be little cumbersome. So frec, I need to check the entry of it, if le exists in frec, otherwise insert I think insert, okay. If this entry does not exist, then insert with this entry with the 0 value, and then increment 1, okay. So this is essentially I'm saying like frec of le plus equal to 1 or plus plus, okay. So in similar language this will be frec of le plus plus, okay. So this is just Rust things. Cool. Then what I need to do is I'll be creating my answer array. So I'll be saying let mut ans, I need a vector of i64, and I will initialize it to of n values, of 0 value with n values, okay, of n elements. Cool. Then so I'll be breaking up my task, okay. So I know this part, oopsie, okay, I know this part is kind of related to my prefix, okay, because here it talks about like my how many elements to the left of my current index, including my current index, are of the same element, okay. And this guy talks about the summation of all the indices that contain the same value as my current index, and like including my current index, okay. So these are my kind of left contributions, okay. So I'll be computing them in a single for loop, okay. So I'll be creating 2 more hash maps, okay. I'll just copy this line, okay. So one hash map will be storing my count, okay. Basically how many indices containing value same as, let's say, pk. Okay, I'll show you how it works. And another as left sum. Okay, basically the summation of all the indices. Okay, now I'll simply iterate over from I in range n. Okay, so I'll get the element, so this will be nums of I. Okay, then I will update my left count. Okay, so same as this line, I will just copy this line. I don't want to write this. Okay, so here I'll say left count. Okay, so I'm upgrading my element count to 1. Okay, I have seen this element once. Okay, then I will also do I'll also increment my left sum to I value. Okay, basically the sum of index. Okay, cool. So this left sum is equivalent to this summation. Okay, and this left count is basically for this k. Okay, so using this left count I can get the answer. Okay, so I'll be saying let's create one more few variables. So count will be left count. I'll be getting le. Okay, how many times I have seen le to the left. Okay, I need to use unwrap, and I'll say 0. Okay, so these are just rust things. Okay, I'm basically saying if it gives none, okay, then simply just give me a 0 value. Okay, then I need to get the frequency. So frequency I can easily get same syntax, get le unwrap or 0 0. Okay, then I got the count, which is basically k. I can write it as k then. Okay, k f or I can say m. Okay, then I need this summation. Okay, so I'll say let's say sum. Okay, and this will be the left sum. Okay, so the summation of all the indices that contains my le. Okay, so with this I'll be updating my answer to something like this. Okay, answer plus equal to 2 times k minus m. Okay, k minus m times pk, which is I here. Okay, and I have to say I as I64. Okay, because these are like I64s, so this guy needs to be of I64. Cool. Then I'll be subtracting the prefix sum that I have gotten. Okay, which is this sum. Okay, minus sum. Okay, this is essentially this part. Okay, cool. So I have computed my left contribution. Okay, now I'll be computing my right contribution. Okay, so these are basically all the indices summation. Okay, whose value is same as my pk. Okay, so I'll be creating one more hash map. So I'll say right sum. Okay, so this will be of hash map I32 and its value is of data type I64. I'll saying hash map new. Okay, cool. Now here this will be acting as a kind of suffix sum. Okay, so I'll be going in the reverse direction. Okay, because I need to get the value from k plus 1 to m. Okay, so I need to go in this direction of nums. Okay, so that I can get the suffix sum. Okay, so I'm saying I in range 0 to n in reverse fashion. Okay, so le, it's nums of I. Okay, I'll be updating my answer of I as plus equal to the right sum of get le. Okay, how many times on the right I have seen this element. Okay, so basically right sum is saying like so the summation of all the indices containing my le to the right of my current index. Okay, so here it will be also unwrap or le. Sorry, this will be 0. Okay, and after this I'll be doing the increment. Cool. And where is this? I will just copy this line and I will write it as left sum. Cool. Now if you see here, okay, when I was doing left contribution, I was doing the summation first, okay, because here I was saying I am counting the element also, okay. So for my ith index is also involved in my left contribution, okay, but when I'm doing for my right contribution, okay, I don't want to contribute like count the contribution of my kth of my pkth index twice, okay. So I will exclude my pkth contribution, okay. So I will only start from k plus 1, okay. So that's why I'm first finding all the right elements contribution summation, okay, then I'm including my current element in the summation count, and this will be like I as 32, I as I64. Cool. With this I can return my answer. Now if I run this, I hope it will run, it will not throw any error, but yeah, it's just Rust. It will throw error. Oh, this will be I64. Whew. Run. Forest run. Cool, it ran. Cool. I hope it, yeah, it's accepted with a runtime of 39 millisecond, which I'm not sure whether this is the correct runtime, but yeah, cool. Now let's look at the time complexity. Okay, so if I look at the time complexity, so what are we doing? Okay, so first I'm creating a hash map. Okay, this hash map is kind of unordered map in C++. Okay, but as per the problem statement, okay, so we should always try to avoid unordered maps, okay, but because in unordered maps lookups can become linear time complexity, they are not always in constant time complexity, okay. But if I consider, like if I assume, like let's say the lookup time is constant, okay, so all this entry updation, those will be constant. So here I am basically so for this for loop, the time complexity will be the big O of number of elements, okay, considering lookups are constant, okay, plus, so all this answer creation, this is also linear, but I will not consider it. Let's only consider the for loops, okay. Now here I have another for loop for the left contribution. Now if I look at all the lines, okay, this is constant. Now updating the value constant, also updating the hash map constant, okay, getting the values constant, and calculating this constant. So here also the number of elements basically I'm traversing on the left side, okay. Now similarly on the right side, similarly on for the right side, okay, I'm basically traveling in the opposite direction from right to left, but if you see, I'm again touching all the elements, okay, and here all the calculation in between are like constants, okay, assuming like lookup times are constant. So again big O of n, okay. So with this I'm getting overall time complexity of big O of n, which is big O of number of elements, okay. Now if I look at space complexity, okay, so for space complexity, if I look at it, so I'm creating 1 2 3 and 4 hash maps, okay. So 4 hash maps, and each of them will be storing the number of elements of the array times like elements, okay. So I'm kind of big O of like 4 times of big O of n, you can say, okay, which is equivalent to big O of n, okay, because 4 is not that big. Cool. So these are like the space and time complexity, okay. So here again note, assuming lookups are constant, okay, in unordered map, okay. But a good thing will be like to use some kind of a ordered map here, okay, because that can always give you logarithmic time complexity, okay. Cool. So this is Rust code, it got accepted. Now I can show you Golang code, so that is also pretty like similar, okay. As you can see, the Go version, I'm also storing the number of elements here. I'm creating a frequency map. I'm storing all the frequency, which was this line, okay. Then I'm creating my answer variable. I'm creating 2 more hash maps, okay, for storing the number of indices to the left, which are having the same value as my current index, okay. And similarly, the summation of all the indexes which are storing my current element index, like current index value, okay. That is left sum, same as what I did for Rust, okay. Then yeah, the updations are also same, okay. Now the pretty cool thing about Rust is like the range is kind of the enumerate version which you will get in Python. Okay, so I'm directly getting the index and the element, which you will not get in C++ or even Rust. So that's why Golang, fantastic. Cool. So I'm calculating the left contribution, and yeah, then I'm calculating the right contribution, and I'm going in the reverse direction because I'm doing a suffix calculation. Cool. So with this is the Golang code. Okay, this has the same time complexity as Rust. Okay, now if I submit, I should get as accepted. Yeah, cool, got accepted. Cool. Now I'll show you the C++ version. Okay, now for the C++ version, when I did this question for the first time, I did it in C++. Okay, and I just wrote all my thoughts. So this is the same thoughts that I explained to you guys here. Okay, cool. Now if we look at the C++ version, like this is kind of the parent version. Okay, so you can see like I'm again creating this n variable which is storing the number of elements. Then there is this another map for frequency. Then I have left count under left sum, which will be storing I think I did this, I don't need this. Yeah, cool. With this, yep, yeah, cool. So with this there is this left count, with this I have this left sum, and yeah, the calculation part is pretty similar to as Golang and Rust. Okay, so yeah, we can see the codes are pretty identical. Okay, only syntaxes are different, but yeah, the idea is same, only the implementations are different. Cool. So with this, if I submit this, I should get accepted. Cool. So we got our acceptance, so we are somewhere here, and the time complexity is fairly like this. Okay, since I have used another map. Cool. So I hope you like the explanation. I try to keep it simple and a bit mathematic. Okay, so yeah, if you guys have any doubt, you can write in the comment. If you like the video, please do like and subscribe to the channel. It will help me and also motivate me to make more videos. With that, thank you, bye bye.